In this video, I'm going to give you ways to prove triangles congruent. Okay, the first two ways to prove triangles congruent, and something to keep in mind here, that these first two are postulates. Okay, which means we accept them without proof. So I'm just giving this to you, you have to accept it without proof. So side, side, side. So if one side of one triangle is congruent to a side in the other triangle, and then I go another side is congruent, and then the third sides are congruent, then we know that those triangles are congruent. And again, remember our congruence statement is, let's start with triangle ABC is congruent. Now remember how I name things is important. So side AB is congruent to side ED or DE. But I have to name this correctly. So I have to start with the angle that is congruent to angle A. Well, I see that angle A is between the side that is marked with 1 hash mark and 3. Look now on triangle, on the other triangle. So I had 1 hash mark, 3 hash marks. So I have to look for 1 and 3. That's angle D. So angle D, so I went A to B. I went D. Now I have to go to angle E. And then B to C. E to F. So those are my congruent triangles by side, side, side. It means 3 sides are congruent. Now we have side, angle, side. Now I think about this kind of an interesting way. So I think about it as when you're saying side, angle, side. Think about my pencil or my finger. I'm marking off my triangle. So I go side, angle, side, and I don't lift up my finger. Okay, so again, I go side, angle, side. I don't lift up my finger. Now I have that in my other triangle. Side, angle, side. And again, writing my congruence statement, I'm going to go triangle ABC. Now I have to figure out, okay, I started with angle A. I start with angle D. Then I go to E. I go to F. Just happens that they're the same on both of those slides. Both of those. Okay, now these are actually theorems. We could prove these if we wanted to. I'm not going to go through a proof with you for a couple different reasons, but just understand that when we're talking about angle, side angle, we have angle. So an angle, I connect out my side, and then I go to my angle. Angle, side, angle. So again, think about it like you're tracing it out with your finger. So I would have triangle ABC congruent to triangle. I started with A, which I'm going to erase so I know what my markings were. Okay, A had 2, so I have to go to my angle that has 2, D, E, F. I think I stole these all from the same place. Now, angle, angle, side. I think this one's actually a postulate. And I think this one's a theorem. I can't remember exactly. And if I can't remember, I'm not going to expect you guys to remember. Just kind of fun. Angle, angle, side. So if I have an angle, angle, and a side. And you kind of have to be able to lift up your finger for that one. Angle, angle, side. Now the difference between these two. Angle, side, angle. Your side is between your two congruent angles. But here, when we're talking about, didn't want to do that. When we're talking about this other one, when we're talking about angle, angle, side, you have angle, angle, and the side is not in between. So my side is not in between the two angles that are marked equal. Again, writing your congruence statement, triangle ABC, congruent to triangle. Again, I started with 2, so that's D, E, F. Okay. And then we have a last one, and this is hypotenuse leg. Okay, and I'm going to highlight this. Hypotenuse leg. The only type of triangles that have hypotenuse are right triangles. So this is right triangle specific. Okay, so this is only right triangles. So if I have the hypotenuse of a right triangle congruent to a leg of a right triangle, we can say triangle ABC is congruent to triangle. It started with A, so let's start with D, E, F. And I think all of those triangles were always congruent. I was listing D, E, F was the same in each and every one. Okay, state if the two triangles are congruent. If they are, state how you know. Okay, so they don't always give you all of the information. So state if the two triangles are congruent. So in this first one, I have an angle and an angle. I have another set of angles. Now keep in mind that I have a side that's included between them. So these would be congruent by angle, side, angle. Angle, side, angle. Angle, side, angle. Okay. Now number 2. I'm just trying to zoom in a little bit so you can see them a little bit better. Okay, so we have 2 of our sides marked. We have one side that is common between those, so it's congruent to itself. So that's congruent by side, side, side. Number 3. Okay, it's a right triangle. So think, okay, can I use that special right triangle? Okay, so I have the hypotenuse, because remember the hypotenuse is opposite of your right angle. And then I have this common leg, so those are congruent by HL. Number 4, okay, we have sides, so I don't know anything about these third sides. Though they look equal, I can't assume that, because you know what you do when you assume. But I have here a vertical angle formed, which just happens to be the angle between the sides. So this is going to be side angle side. Number 5. Okay, so we have one side marked. I can assume vertical angles equal. I don't know anything about any of these other sides. They look like they're equal, but I don't know. I have no markings. So these would be not congruent. And then lastly here, number 6. Okay, so I have a side. I have an angle. So I should probably be deciding between side, angle, side, or angle, angle, side. Okay, for this first one, you'd have to have this side equal. So you'd have to have that side equal or congruent to that side. Now they're not. We don't have any markings. But again, I've done a few examples of this already. We have these vertical angles in here equal. So it's not side angle side. It's angle angle side. And again, your angle angle side is angle angle side. Okay, angle, angle, side. Okay, and that is my video on proving triangles congruent.